Good morning. I'd like to welcome everyone to our webinar that's going to discuss benefits of a combined FlashPrep system. My name is Ron Lose. I'm the Product Marketing Manager for Chromatography here at Isco. What I'd like to do is just walk you through some examples of what you can do with a FlashPrep system and talk a little bit about the history of Flash in general. So we'll get started. The idea is that flash chromatography was commercialized in the late 1990s, and since then, over the last 20 years, it's gone through several iterations of product design. The different iterations has increased the flow rates, built systems that's able to withstand higher pressures, added a lot of capabilities, a lot of detector options. The first flash systems were primarily a mono wavelength at 254 detector. Now we have UV visible photodiode array detectors, evaporative light scattering detectors, and even mass spectrometer detectors that can be interfaced to flash systems. The other thing that's made a big change is software control. The first systems were fairly analog control, a lot of user dials to be set. Anymore, it's all a graphical touchscreen interface, very simple to use. It's been automation added so that you can run multiple columns in series on the flash side of the system. And all of those changes have taken place over the last 15, 20 years. So from a very simple system to a much more complex system. However, the drive here at Isco has been to maintain the simplicity of the user interface, even though we've added a lot more complex capabilities into the system. Just a little bit about the benefits of a flash chromatography purification. Well, obviously, flash chromatography insinuates that it's fast. Today's systems with flow rates up to 200 mils per minute and pressures operating up to 200 psi, you can do very milligrams to grams purifications in a matter of minutes. What could take, before on the earlier flash systems, could take up to hours or even almost a day, can be done in less than an hour at this point. The other thing is it's a low cost when compared to HPLC. Columns are disposable if they're silica-based, normal phase columns. They're designed to be a single-use column, and once it's had the purification performed on it, it's discarded. In the last 5-6 years, there's been a lot of movement toward reusable reverse phase columns. And again, the material, the media is a larger pore media, larger diameter particles, and therefore it's less expensive than preparative HPLC columns. But again, at the same time, they're reusable. So I've seen columns in customer locations that are reverse phase that's had well over 100 to 200 injections on them, and they're still performing well. Really, just like in HPLC, depends upon the purity of the sample and how with the care that you take of your flash reverse phase column. Alluded to it a little bit earlier, wide sample size, the ability to separate milligrams to grams in a single injection. That's really the one of the big benefits of flash chromatography over preparative HPLC systems. Drawback, well, those same large columns actually are fairly low efficiency when you compare them to prep. A prep column today is 5 or 10 micron particles. A flash column has a wide particle size range, somewhere between 20 to 40 micron. And so that leads to lower efficiencies. So the end result is sometimes the purification doesn't always achieve your target purity levels that you're trying to shoot for. So let's talk a little bit about the benefits of a combined flash prep system, and then we'll go through some applications to illustrate those. With a combined flash prep system, on one side of the system you have a flash that's good for fast purifications, and at the same time, when you need that additional separation or resolution afforded by a high-performance preparative column, you can easily switch over to the prep side and run your sample there. So if you've got your flash for fast, you've got your high performance for difficult purifications. Teledyne Isco introduced in 2015 the CombiFlash EZ Prep system. And if you look at the system, you'll see here on the left-hand side of the system, this is the traditional flash side of the system, so low pressure system on this side. Over on the right-hand side of the system is the high pressure, high performance column, preparative column, and the liquid injection valve located up here. So the EZ Prep is a chromatography system that's capable of running both flash and high performance or prep purifications. Flow rate range is 100 or 1 to 200 mils per minute on the flash and the prep side. So actually should be 5 to 200 mils per minute. The EZ Prep cannot go down to 1 mil per minute. But that's applicable to both the flash and the prep sides. 200 psi on the flash side, and on the prep side it goes up to 3,500 psi. So the 200 psi side is simply software limited because the plastic columns can't withstand pressures much above the 200 psi mark. EZ Prep has all the variety of detectors or choice of detectors that is on a traditional flash system, so UV, UV-Vis, evaporative light scattering, and mass spec. Other detectors can be interfaced to the EZ Prep using an external detector port. So you could hook up a refractive index detector or a radiometer detector if so desired. The other thing is with the CombiFlash EZ Prep system, it very quickly switches between flash and prep. Let's just give you a quick example of that in a minute. But why the EZ Prep system was designed? We talked to customers before when we started considering designing the EZ Prep. We found that a lot of the customers, 80% or more of their time, flash is adequate for doing the purification. However, for 10 to 20% of the time, the flash resolution is not adequate, and so therefore samples needed to be diverted to the preparative HPLC systems. Now, typically, a preparative HPLC system required skilled chromatographers to operate. The software is fairly complex, whereas the EZ Prep was designed to provide simple operation using our Flash Peak Track software user interface. It's a graphical user interface. It takes probably 45 minutes to learn how to use the system, and so a new user can be up and operating this system fairly quickly. That's very contrary to a preparative HPLC system, which has a lot of parameters that aren't required for purification, but are a carryover from the analytical data systems that the preparative HPLC systems were traditionally derived from. The other advantage is you can get faster turnaround time. If you've got a larger corporation, a lot of the preparative HPLCs are are driven by centralized service labs, and so samples have to be submitted, and so lead times on getting a purified sample can be a matter of hours to a matter of days before purified samples return back to the bench chemist for use in the next step in a sequence. The other thing is that the EZ Prep system takes up minimal hood space. All of our flash systems are typically located in a fume hood because of the organic solvents that are used in flash systems. And so hood space is at a premium, and we recognize that, so we maintained the small footprint for the EZ Prep that's very similar to the footprint of our CombiFlash RF Plus systems. Just some of the key features of the EZ Prep. We talked a little bit about this. Pumps are high-performance HPLC type pumps, which is different from the traditional CombiFlash RF Plus flash system pumps. Capable of 3,500 psi up to 150 mils per minute on the prep operation, and then the pressure decreases, maximum pressure decreases down to 2,500 psi at 200 mils per minute. System is auto priming, so there's no use of a syringe or something else to pull solvents through the lines. It's simply a button that you press in the user interface to begin the priming process. Flash injections are done on the left-hand side of the system, and they can be either a liquid injection or a solid load cartridge can be used for introducing the sample onto the flash columns. On the high pressure side, the injections uses a traditional loop injector that's electrically actuated by the system. And the other key feature is inside the unit there's an electrically actuated flash to prep selection valve that automatically switches the flow path between the flash and prep modes. So going from flash to prep is easy. It's just 2 clicks to go from flash to prep. If you were in the prep mode and you want to go back to the flash mode, you can simply install a ReadySep or ReadySep our gold flash column, and the system will recognize it and automatically switch back to the flash side. In order to avoid confusion about which mode you're operating in, we've color-coded all the screens. So if the screen has a blue background, it's in a flash mode. A green background indicates that you're operating in the high pressure or high performance mode on the system. So we talk about switching being easy. This is the default screen that comes up on the unit when it boots up. And we always have a silica column loaded down here. And so by clicking on this down arrow, you get this list of columns. And just simply choose your HPLC, prep HPLC column on this list. HPLC column is then loaded onto the screen into this position. A default method that's housed in the software is generated, and if you're happy with these conditions, you simply press the play button and that starts the run. So that's the 2 clicks, one to choose your column off of the drop-down menu, and the second to press the play button to start the purification process. So let's talk about just a few examples and what some of the things that you can expect from this. This is a thymosin, or a small peptide. It's a purification. This top chromatogram here is a chromatogram showing a scouting gradient run on a flash C18 column. And what we've got here monitoring is there's 2 different masses from the mass spectra. that we've collected, and then there's three masses, the dark blue, the light blue, and then the teal. And then the red, and then there's a purple or magenta here, and that's the two wavelengths, 254 and 214. So you can see that we've got a fairly broad peak here, not an adequate, even though we've kind of hard cut this using the mass spec. Analytical analysis showed that we didn't have purity of about 60 or 70%, which wasn't adequate for the target peptide that we were looking at. So if you look at the run down below, this is run on one of our ReadyStep prep columns, which are 5 micron. On the other side, on the right-hand side of the EZ Prep, changed our gradient conditions somewhat so that we can get a little better separation. You can see that there's still a lot of closely eluting peaks, which you would expect. This is a peptide thymosin, and this sample was run on a microwave synthesizer for peptides. So you would expect to see some of this where there's one or two amino acids missing out of the chain. However, mass spec shows that this is our target peak right here. So we collected that, and we've got about 85% purity. For some applications, that's sufficient for us to be able to move on to whatever the next step in the process would be. So you can see the difference right away between a lower resolution Flash C18 column versus a high performance preparative HPLC column. This is an example of organometallics where we've formed a ligand that then bonds with the palladium or platinum. And we've purified that, again, using a mass spec. We can see that here's our target mass, 324. That's the blue line here. Surprisingly, little UV. We've been monitoring 254 and 214, which is our defaults. We probably need to go back and look at the UV spectra so that we could get a more appropriate UV wavelength to monitor. But you can see that the mass spec in this case really saved the day by actually finding the peak of interest, and so that was collected. This is actually run on the flash side, and it is a satisfactory purity level that the ligand could be actually used and reacted with the platinum or palladium catalyst to continue the sequence of the synthesis sequence, if you will. Last fall, we introduced the AccuPrep HP 125. This system is dedicated to preparative HPLC. There is no flash side to this unit. As you can see, it's very similar to the EZ Prep in some respects. And on the left-hand side is the high-performance preparative HPLC column. What you can see here is a little bit of the sample injection loop. This is an option that's been added, which is a auto-injector, which will allow you to make multiple injections of the same compound or mixture. So you can do multiple injections while unattended. AccuPrep has a flow rate range of from 1 to 125 mils per minute. It has an upper pressure limit of 6,000 psi, so it can run very high pressures on the columns if necessary. There's an option for the user to set that upper limit. Some of the preparative HPLC columns are not recommended to be run at 6,000 psi. They're recommended to be run around 3,000 to 3,500 for maximum pressure, and so the user can set that pressure for each individual column that that you've built into a column database. In this case, the display is a little larger. It's a 10.5-inch display on the EZ Prep. It's a 15-inch capacitive touch display here. So it operates, it's got pinch zoom, operates very similar to your smartphone, your iPhone, or your Samsung phone as far as zooming in and zooming out on the chromatographic process. I want to show you some examples of purifications of the EZ Prep versus the AccuPrep. This is another peptide that was purchased from a New England peptide. That's a raw material. And you can see here you've got a fairly decent UV signal, but you also have a very good mass spec, and there's 2 peaks associated with the same mass here. So that mass is 546. That's our target compound that we purchased. So what we wanted to do was to purify this to get rid of some of the impurities that were present. And so this is the purification that was done on the EZ Prep. Ran the same sample on the AccuPrep, changed our gradient conditions so it's a little bit more focused. And you can see that right here is our 546 Dalton peptide. And so we've identified which peak it is that we're looking for. And so we've collected that peak. We ran it purity analysis on a micro HPLC system that we have in the lab. And we've got purities of greater than 95% by HPLC. So very quick, easy separation. So if we go back a minute, you can see where these peaks were very closely eluding. Now we have this baseline resolution. So we improved this separation just by the performance differences between the EZ Prep and the AccuPrep. And this is just the amino acid chain that was included in this peptide. So to give you just an example, this is an ester synthesis that we performed on a Anton Par monowave. So we started off with toluene sulfonic acid. This is our other starting material. This is our reagent. This is our starting material. And this is a methyl ester of the so this is methyl parabens, and then this is ethyl paraben. So you can see where we happen to have a mixture of 2 alcohols that we started with, and so our reaction occurred, reducing our starting material, and then it generated 2 different esters in the synthesis process. This is run on a ReadySep column, so typical flash reverse phase separation on a ReadySep's Gold C18. And you'll see that the gradient conditions here are the same for all 3 of these. This is the separation that we got off of the EZ Prep system on the high pressure side. So this is low pressure, high pressure, and then this is the separation we got on the AccuPrep. So you can see the AccuPrep had a little bit more sensitivity, the peaks are a little sharper, and we've got a little bit better resolution between the peaks. Actually come off a lot earlier on the AccuPrep. So kind of gives you an example of what type of purifications you could expect off of the 3 different techniques that involves the EZ Prep and the AccuPrep. So just in conclusion, I just wanted to go through, this is a brief list of the different products in the our Teledyne Isco chromatography family. RF-150 is a low-cost unit for academic use. The RF Plus consists of a UV-Vis unit. The Lumen has the ELSD built in. The Pure Ion on the RF Plus has the mass spec associated with it. The Torrent, which is this large system here, is really for scale up and up to pilot plants. And so you can run up to this column here happens to be a 3 kilo column. So you can run up to flow rates of 1 liter per minute on this system for prepping large multi-gram samples. Of course, we have 2 different lines of columns, ReadySep RF Gold columns, or ReadySep RF columns, which are irregular particle shapes, and ReadySep RF Gold columns, which are spherical, to reduce the back pressure and enhance the performance and resolution. We have a line of fraction collectors that can be operated in standalone mode. We have in the ELSD the 340CF, which is intended to be interfaced with the Torrent system. It's a standalone box that sits beside the Torrent. And then we have 3 different detectors, SOFTA detector, ELSD detectors, that are for analytical use. Keep in mind that all of our systems are compatible with the iPod, iPod Touch, the iPhone, and the iPad. Also can be controlled through a desktop browser. So you don't have to go to the lab to see what's going on with the system. You can catch up on your paperwork while sitting at your desk and act as long as the systems are networked on your backbone of your network in the lab, they can be called up by their IP address in your office, or if you've got a mobile device, they can be called up on your mobile device. You can make changes on your mobile device. You can change your gradient profile. Likewise, you can change it from your desk. You can start and stop the system, and you can view any system messages that might come up in case you, for example, if your solvent becomes low, we do have active solvent sensing built into all of our systems, so they will stop the process and alert you that the system needs additional mobile phase to continue to complete the run. So as a final thing, again, I'd like to thank you for the time today. There is a very useful book that's available at no charge. It's our Guidelines and Tactics for Flash Chromatography. And even if you're doing preparative HPLC, there's a lot of good information about solvent selectivity and solvent strengths that can be found in this guidebook. That you can access it at info.teledyneisco.com/flashguide. If you'd like more information, you can certainly contact me. My phone number and email address are there. We do have upcoming flash chromatography webinar topics, so one of those is, well, several of them are listed there. Introduction to Flash Chromatography is a basic webinar that we do on an annual basis, typically for people that aren't currently doing Flash, so they want to understand more about what Flash is. Thank you for your time. I hope you found it useful today, and so we'll see if we have some questions. Let's try to answer those. Okay, so one of the questions that was asked was, how do I decide what model of system, whether I would want an RF Plus Flash system, an EZ Prep system, or an AccuPrep system? There's some guidelines that might help you. There's a technical note number 33, which is choosing the right system. And it does a technical comparison of the 3 models and kind of gives you some highlights and the focus of each one of the 3 models. Another question is, can I automate the EZ Prep? And the answer to that is yes. There's two ways you can actually automate the EZ Prep. If you're interested in automating the flash side, there is what we call a 4X module that can be attached to the left-hand side of the system, and that allows you to pre-prepare 3 additional columns for purification by flash. And so then as those columns are, as the first run's completed, it goes to the next column, and they're all queued up in series. On the high performance side, both the EZ Prep and the AccuPrep, there's the auto injector, which I mentioned, available, which allows you to program multiple injections of the same sample out of the same sample vial or flask. There's a column switching module which allows you to pre-plumb the system with up to 4 preparative columns, and then you can switch and choose which column you want to use. And for real true automation, there's an auto sampler that's provided for the high performance side of the EZ Prep, and that auto sampler allows you to inject multiple samples, different samples, and do multiple injections of each of a number of different samples. It also adds 2 additional racks, so it doubles the collection capability of the system. So several different options. And someone's asked, what is the maximum size of a column in the Torrent system? The maximum size column for that is a 3,000 gram column. It can be silica or reverse phase material, depending upon your application. What about the solvent grade to use with the EZ Prep? Do you need to use HPLC grade? Also, if you run the flash side, typically we don't use HPLC grade here. We use more the lower technical grade, which is used on the flash side. We use that on the HPLC. If you're using the mass spec for detection, it requires a carrier fluid. And so with the mass spec, the carrier fluid we normally recommend is mass spec grade solvents there. But for the purification part of that, with the mass spec interface, we still use technical grade. So, it really depends upon your goal. If you're shooting for 99+%, you need to use solvents that are more appropriate. So in that case, you probably should use HPLC grade solvents. But for normal applications where you just need 90+% on the prep side, you can get by with the technical grade solvents. Okay, I think that's the end of the questions. So again, thank you for your time. I hope you found this to be somewhat informative, and I hope you have a super rest of the day. And thank you.